When we think about settling Mars, we picture bustling glass domes and sprawling cities. The immediate future of Martian settlement is dark and isolated. There are 3 phases of colonization. Phase 1 is happening now with robotic rovers. Phase 3 is that thriving metropolis. Between them lies because Mars is so far from the sun, solar energy is less than half as effective as it is on Earth. Without a global magnetic field, the surface is constantly bombarded by cosmic radiation. Building the first outpost is the most punishing biological and engineering survival test in human history. Arriving on the surface is a physics problem. The Martian atmosphere is too thin to support a parachute for heavy cargo, but it is thick enough that spacecraft will burn up if they enter too fast. Keeping the lights on is the next hurdle. Mars experiences planet-wide dust storms that can block out the sun for weeks, rendering solar arrays useless when the crew needs them most. To guarantee power for life support, the outpost requires heavy nuclear fission reactors shipped from Earth and deployed on the surface. We cannot rely on the Martian environment for baseline energy. We have to brute force heavy Earth technology onto an unpredictable alien landscape. Habitats require rounded walls to handle the pressure differences between the interior air and the exterior vacuum. To block radiation, these structures will likely be buried under thick layers of frozen carbon dioxide. This flowchart demonstrates a mandatory survival process called In-Situ resource utilization. By mining local water ice and extracting carbon dioxide from the air, the base can chemically synthesize breathable oxygen and rocket fuel. Technology can only protect the body so much. This NASA assessment highlights the dangers of altered gravity fields. Mars has just 38% of Earth's gravity. Over time, that causes bone loss and cardiovascular deconditioning. If a system fails, the crew is alone. It takes up to 22 minutes for a radio message to reach Earth. Rapid rescue is impossible. Phase 2 astronauts are isolated subjects in a biological endurance run where a single broken valve kills everyone. If the crew survives the physics and the biology, the primary threat shifts to human governance. Managing a closed-loop society means managing extreme scarcity. Researchers propose diffuse capital ownership, distributing infrastructure ownership across the population. This prevents a central authority from monopolizing life-critical systems like air production. To prevent corporations or nations from stripping the planet, early legal models suggest strict bounded land possession, designating protected planetary parks. Growing food will take up most of the crew's day. We tried building closed-loop ecosystems on Earth with the Biosphere 2 facility, and with a massive greenhouse and 8 people, we couldn't make it work. In an outpost where everyone must work to maintain the machinery, what happens to the permanently injured Hellenists? What happens to children born in low gravity whose skeletons are too weak to ever visit Earth? Establishing a permanent Martian outpost forces us to solve ethical and resource dilemmas that we actively avoid on our own planet. Phase 2 means physical danger, an extreme cost, and terrifying ethical nightmares. But humans are an expansionist species. We challenge hostile frontiers because the struggle forces our technology and our society to evolve. Building a Marsbase is a horrible idea. But the grueling crucible of Phase 2 is the cost of entry for a species that refuses to stay on one planet.